Good morning, good afternoon, wherever you may be, and welcome back to day two of Streaming Media Connect 2025. I'm Steve Nathans Kelly, editor-in-chief of Streaming Media Magazine, and I am pleased to welcome you all to today's first session, Cut to the Quick. Can Media Over QUIC and WebTransport solve streaming latency? We have an all-star panel for you this morning featuring two 2025 Streaming Media All-Stars. But before we get started, just a few housekeeping notes. And actually, before we get started, the housekeeping notes, I just want to say this panel is brought to you by nanocosmos, and we're very happy to have nanocosmos here. And so the music you were hearing as we were walking in, so to speak, the first person to correctly identify the track and the artist that you heard will win a $50 gift card from Amazon at the end of the session, but you must be present to win. Sessions from all 3 days of Streaming Media Connect this week are already appearing on the Stream Media YouTube channel. The link for that will be in the chat. And we will be back live and in person October 6th to 8th in Santa Monica, California for Streaming Media 2025 with our incomparable conference chair, Andy Beach. The full program for that is live now, but we're still filling the sessions. So if you check out the program and you see a session you might want to join, see where your expertise would fit, just respond to the call for speakers and let us know what topics would be suitable for you. And so without further ado, I would like to bring to the stage Timothy Fore-Siglin of Help Me Stream Research Foundation. Morning,
Thanks.
Tim.
Morning. How are you doing today?
Good to see you. I'm going to step back and let you take over. So.
Okay, thank you. And I'd first like to call to the stage Oliver Lietz. Oliver, thank you very much for nanocosmos putting this together. Tell us just briefly about nanocosmos.
Sure. I'm the co-founder and CEO of nanocosmos. It's going back to 1998. So we celebrated over 25 years already with our company, starting in the video industry, in the broadcast industry. And now we put together a complete live streaming platform for ultra-low latency live streaming. We were kind of pioneering this, and we are upgrading this, including the CDN and the last mile to QUIC and WebTransport. So it's a great topic, which fits perfectly from timing into our timing, and I'm happy to share some insights about that in the session. So one thing I wanted to share is that it's European-based. We are based out of Berlin, so the whole technology is created and built in Europe. That's something I want to point out from time to time.
All right, very good. Thank you for that, and look forward to your insights in this. And then I'd like to bring Will Law from Akamai up to the stage. Will, I would assume most people know what Akamai is, but maybe for those who don't, if you can describe it and then sort of your role within Akamai.
Yeah, certainly. So firstly, thank you for the invite, Tim. It's a pleasure to be here and also to be talking with Oliver. So Akamai is in our 25th year, I think, at this point. We are a security company, a cloud compute company, and a delivery company. Many people probably still think of us as a CDN, but the majority of our revenue today is non-delivery based, as in fact in compute and security. And the compute side is really interesting. We're seeing a lot of growth there. My role is one of the chief architects inside the Cloud Technology Group, which is a division inside delivery. So I care about media. I've been at Akamai for 17 years now. So I've seen the transition of media way back from Flash days, going through segmented media, and right now up to what I think is one of the newest and more exciting evolutions of media, which is Media Over QUIC.
Okay, fantastic. Thank you. And so for those who may not understand what QUIC is, let's sort of start with QUIC. And Will, I'll ask you to define this. What exactly is QUIC and why should they care about that?
Well, QUIC is an evolution of a transport protocol for the internet. So the internet, and maybe I can show my slide at this point of
Go ahead.
The various protocols that we have. Let's just go to full screen. So all of the media on the internet today is delivered by one of the four protocols currently on the screen: HTTP1, right? TLS, TCP. over network IP. And then HTTP3 introduced this notion of QUIC, binary transport, right? QUIC having a notion of streams within it and datagrams. Streams being parallel flows, reliable flows of data, and datagrams being unreliable.
And just for the audience, sorry, streams are not necessarily video streams. These are streams of data.
There's a lot of overloading of the term stream, right? We're going to say it a lot. It has a very specific meaning inside QUIC and inside WebTransport. WebSockets also used very successfully, right? It gives you a pipe. And it's important that it's a pipe, though, that is head of line blocked. Whatever you put in, if you put multiple things in, they can block each other if any one of them becomes stuck. But it's very useful for delivering payloads of your choice. It also provides its own framing, meaning you can send messages and you know where the message begins and ends. WebRTC then is what many of you are using right now to listen to us and watch us. WebRTC is a beautifully complicated stack. I think there's approximately 20 standards that are referenced, both to define the codecs. It's a P2P-based protocol, so session establishment, how we control it, how we provide feedback, and how we move data. So the interesting thing about WebRTC is it's a black box in many cases, right? It's very hard to go in and drop your own codec in there. We are seeing codec evolution coming out now, but it's taken a long time. The beauty of WebRTC is its reliability, right? As long as all the browsers support it and other OSs, we can have conversations.
And before you go, well, okay.
Too late.
Let me just make this comment before you talk about WebTransport. If the audience hasn't noticed, essentially WebSockets in HTTP 1 and 2 run primarily on TCP, which was the good neighbor policy, the way that we approach things. H3 and WebRTC, and to a certain extent, WebTransport, run on UDP, which has been around since the time of TCP, but really had been ignored, so to speak, because it didn't behave nicely on networks. So I just wanted to point that out for the audience, Will.
That's great. I can do a UDP joke. I'll tell you a UDP joke, but you might not get it.
Exactly, precisely.
Okay. So, WebTransport. You see here, built on top of QUIC. So our QUIC stack is symmetrical here. We have we have a QUIC HTTP3 layer, which is used for a session establishment with WebTransport. And then after that, we have nothing more to do with HTTP, right? It's only there at the very beginning. After that, our WebTransport layer is leveraging these streams and datagrams that are inside the QUIC layer. WebTransport has a failover mechanism. If you can't establish a QUIC connection, it can also operate over HTTP2, but in a mode where the datagrams are curiously reliable. So it's not as preferred mode of operation, but we mostly today operate over QUIC, and that's where some of the advantages that we can extract from that protocol start to come out. So WebTransport, and to be also very clear, WebTransport is just a pipe. It's a pipe in which I can have many parallel streams of data along with datagrams. But there's nothing inherent in it. Nothing's going to move. I need to define the protocol that is going to, the two endpoints are going to talk to each other. That it is nothing more than an empty pipe.
Okay, fantastic. So if we'll take that down and come back to face-to-face. So a couple quick questions on that. One, what's the difference between WebTransport and QUIC, or media over QUIC transport?
So different things, right? We saw WebTransport uses QUIC in order to establish this pipe between a client and a server. WebTransport is also client and server based. It is not P2P based. The session is established by a client and it negotiates the session with the server. Media over QUIC is an umbrella term. Media over QUIC includes an actual protocol which is called Media over QUIC Transport, MoQT. This is what is being standardized by the IETF. All the work is public, and I encourage everyone in the audience to go there and look. There's a whole lot of issues that we work through. All the minutes are public. We even have YouTube videos up, so you can be involved in the nuts and bolts of the development of Media Over QUIC transport. It's a very active development space right now. So Media Over QUIC transport can leverage WebTransport, or it can use what we call raw QUIC. In other words, QUIC without this HTTP layer for establishment. And MoQ transport is a pub-sub protocol, publish, subscribe. So it's not a request mechanism like we're used to with HTTP, where you ask for a resource and you receive it. With a pub-sub system, you ask to receive what we call tracks, which are linear flows of data. And a subscriber subscribes to a track, and a publisher sends that track to all the subscribers in highly simplified language.
Okay. So
yeah, it's not actually defined in terms of media. If you go to the MoQ transport spec, we're very careful not to bind it to media delivery, even though it's in the name. So,
and we'll come to a little bit of that later. One last question on this then. So we've got the Media Over QUIC transport, and we've got WebTransport, and we have raw QUIC. What would be sort of scenarios where you would use raw QUIC versus what is envisioned with the MoQ transport?
So again, raw QUIC is not an alternate to MoQ transport. MoQ transport is this pub-sub protocol. Underneath it, it can use WebTransport or raw QUIC between the endpoints. A case where you would want your MoQ transport to use WebTransport would be someone like a CDN. Why? Because with WebTransport, you inherit TLS and all the security that comes with domain names and DNS and discovery. That works at scale. We build an economy on it, and we want to leverage it. However, if you're someone like a video conferencing vendor and you own all the endpoints, the publishing, the relays, and the subscribers, you don't need that HTTP overhead that comes with WebTransport. You can leverage QUIC directly. So that would be a case where you might want to use QUIC, where you basically control the vertical ecosystem. But for a CDN that has to interop amongst many different clients, we would prefer WebTransport to be the interface.
Okay. All right. Thank you for the clarification. So Oliver, you mentioned this is sort of a European developed concept. And I know you were saying up front, you like to remind people of that. Did it come out of a specific need within Europe, or was it something that groups saw that would be a global challenge that needed to be addressed?
It's a global challenge, and we were also always operating at a global scale. It's just that the technology was created in-house, and it came out of the need 10 years ago when Flash was disappearing, that there was still a need for interactive applications. So we decided to build something which really works, which is enabled for real-time activity, for real-time interactivity. In this time, there was also the WebRTC stack evolving, so it came to the market, and we decided carefully what should we use for building our platform, and we decided not to use WebRTC for delivery because it creates a lot of challenges. As Will was mentioning, it's a beautifully complex stack that tries to hide all the complexity under complicated architecture, and not every browser behaves the same, and it's not designed to be used for live streaming. So we are working on the live streaming space, one-to-many broadcast style scenarios. We have a large audience all around the globe, a bit like the CDN model, and that didn't work for us for the WebRTC when it was designed in that time. And still, I believe, and that's one of the reasons why Media Over QUIC was designed, to get rid of all the complexity of WebRTC, and on the other hand, make it more flexible and easier to use adaptive bitrate, better distribution models for CDN distribution and contribution, etc. So that's why we also picked up Media Over QUIC as a foundation for our next generation platform, and added that both on the CDN level for origin edge distribution, and also for the last mile on the player, because we always look at that end to end. So you brought up a very good overview of the protocols. It's very difficult to understand, even for engineers like me, what are the details, and what the question is, what's the use case in the end? So what do you want to achieve? And customers coming to us, they don't want to worry about these things. They want to have a running solution, which is just working in any browser. You open a browser and you see a live stream. And if it's an MoQ or a HLS or WebTransport, WebRTC, protocol under the hood that doesn't really matter for these users to have a successful user experience. So that's what we try to abstract somehow with our solution, to cover that in an end-to-end scenario, which really makes sense and decide on the use case and on the available network situations, etc., which protocol to use. So it really depends on the use case, and then on the end, what you would like to implement and make available to your end users.
Okay, and we'll come to some of those use cases in a bit. I can say, as somebody who's been in the industry since before streaming started, when WebRTC popped up, I felt like I was either having a deja vu moment because of things like RTP and session initiation protocol, or a PTSD moment because all the problems that we'd had with those early protocols were just sort of glommed together into WebRTC. Will, so you mentioned that people can come help influence this with the MoQ transport. What's the status of sort of the HTTP3 approach to it? And I think that was, if I look at my notes, it's RFC 9114 with IETF. Where do we stand with HTTP3? Because obviously, if we're talking about things beyond just video streams, or we're talking about other kinds of interactivity that Oliver was alluding to, are we at a point where people feel comfortable that they can begin having those conversations and developing around H3?
So H3 and MoQ transport are separate things, to be clear, right? When I say there's a MoQ transport can use WebTransport, and WebTransport has a very thin HTTP3
layer,
connection establishment layer. But after that, we're done, right? We have nothing more to do with HTTP. So MoQ transport is a transport protocol designed to build pub/sub networks, and you could do HTTP over MoQ transport if you wanted to, which probably some clever student will do for a thesis, but it would not be efficient. Pub/sub networks are very good fit for media, because media is inherently a temporal flow of data. It's audio, it's video, it's chat, it's captions, but they're changing with time, and they're also consistently encoded. So in the segmented world, we have to repeatedly ask for little blocks, right? And we use the blocks to do adaptive bitrate. But it's a very clean match to media delivery when I can simply ask for a flow of data that's originated by an encoder and then distribute it out to a relay network and receive it. The big difference between Media Over QUIC transport and WebRTC, for example, is firstly that MoQ transport is client-server by design, not P2P. So it's a much faster connection and session establishment. And secondly, it's designed to be scalable through caching. So today, WebRTC, you can't ask for the data frames from 1 second ago or 3 seconds ago. You get the very latest. And WebRTC is a latency-first protocol. It'll throw quality under the bus. It'll reduce its quality to maintain its latency. You have no knob to say, you know what? I'd be happy with 3 seconds of latency if I can get a large quality improvement for that. But MoQ transport gives you those knobs. It lets you trade off quality and latency and encoding time and prioritization. So it's a very flexible environment to distribute flows of data, and it's a very good match for media delivery.
So it's interesting you point that out about the latency first versus quality and in the knob model. How tweakable is that in practical uses for someone who's developing, say, a player or publishing infrastructure?
It's incredibly flexible. So I have demos, which I won't show today, unfortunately, but anyone can hit me up at a conference and I'll show you. Latency with MoQ transport is tunable. So MoQ transport can operate at very low latency levels. I'm talking 200-300 milliseconds, or basically RTT plus encode, decode, delay, plus a very small amount of compute. So it's the level at which RTP operates, for example, and that is our sort of design parameter. We need to be as good at or better than RTP for media delivery in terms of latency. But at the same time, you can cache objects, and a player can subscribe behind the live edge. So if the live edge is getting repaired, right, and it maybe takes a second or two to repair it, someone right at the live edge won't get the full experience, but somebody who chooses to be 2 seconds back can have a different and improved experience. And someone who wants to be 15 seconds back, say the archive system, can have the optimal experience because there's time to retransmit and repair frames and segments. So when you combine that with prioritization, meaning if I've got multiple tracks at different bit rates, say 3 different bit rates, just like an adaptive segmented world, or I have SVC layers, a base layer and additive layers, I can define the priority with which each individual relay in the distribution chain should write them to the wire. So that if there's contention, it's not random as to which get dropped. I can be very specific about the order and which objects in my flow I want to drop first so that my most important ones are delivered.
Yeah, I can support that. Media Over QUIC and WebTransport is much more flexible than WebRTC, which is really a single monolithic stack somehow. You can't even configure the video bitrate properly. So it's something which is really more used for real-time communication point to point. And its origins were in the video telephony or even IP telephony in the past. So it goes way back, and Media Over QUIC is more meant to be used for live streaming, which is more flexible. You can use whatever codec you want. You can use full HD 4K video, send it over the lines, and that's totally agnostic to that. So it gives a much better, also future-proof stack to add certain things which were coming next then.
Okay, very good.
I also want to back up Oliver's point to say, while MoQ is very good at real-time communication, which is what we're doing now, you can also use it for VOD content, which I don't think a lot of people appreciate. We have a method inside MoQ Transport called fetch. Fetch lets you retrieve objects from the past. And why would you want to do that? Well, I want to watch a movie, right? I just want to retrieve it from object 0, the whole thing's cached, and I can serve it out, just like I do with HLS or Dash. Or I might want to, in my live stream, insert advertising. And advertisements are VOD assets. So I might want to subscribe to those VOD assets on one track, and then on my live track, I have my content. My player can then insert the ad into my live track, and then I can monetize my extremely low latency live feed.
Well, and I was going to say that, sorry, Oliver, that acts sort of as the DVR functionality as well. If I come into
DVR in a live sports game, you can do all the same features. Go back to the try, the basket, the touchdown.
Sorry,
and in the lowest level in the browser, if you open up a web page with a Chrome browser and use a Google service, you suddenly see it's HTTP3 with QUIC, even for static content. So you can already use it, and it's used under the hood, although you don't notice that QUIC is in the game already. So that's definitely working. And with Media Over QUIC and the Media Over QUIC transport and the additional tools, you get even more flexibility for doing that.
So, Will, as you were describing just a couple minutes ago about sort of that being able to choose as the archiving system to be 15 seconds back, I'm going to date myself, but it reminds me of the burst technology from the late 90s, where burst had the VOD content that you could say, I want to watch it at 1.5 megs, as opposed to my pipe only allows 900K. And what I'll do is I'll allow the buffer to fill up until it's guaranteed that I can watch it to the end of the VOD asset at the quality level that I want to. To a certain extent, I almost hear that as a possibility as well. If I'm on a pipe that maybe is intermittent, that I could choose to sort of trail back.
Yeah, you can do that. I don't recommend it. I think there's better solutions. Like that is, I've got 1 bitrate of my asset and a small pipe. So I'm going to trickle it down, and at some point I can calculate when I have enough to play it back without interruption. I remember those days. But today, typically we have multiple bitrates to try to address that. So the preferred implementation would be pick the right bitrate for the pipe that you've got. And if that pipe's fluctuating over time, then you constantly change the quality that you're pulling. If you have the luxury of time and you're just pulling it for the future, yes, you pull the highest copy down at less than real time, and you buffer it in the client, and then you can play it out.
Okay. Well, I asked that because a lot of the work we do with research is on intermittent networks, and this all of a sudden I'm starting to think about some scenarios there that might play well. So there's not that
That's a good thing. And what's one of our biggest problems with MoQ? Because it's very easy to say, oh, I have this connection and I'm publishing and someone else's. I got 5,000 people subscribing to my feed, but all of a sudden my contribution connection goes down. Right. Now what happens? Like chaos happens on the network if everyone does. So you have to be very careful. We have to go through all the scenarios and create all the verbs and the actions in the protocol to accommodate an unexpected drop, a recovery. How does the publisher start resuming? What do relays do when they get duplicate objects? Who wins? There's a lot of complexity in making it resilient over connections which are never permanent.
And part of the idea here is you're building a solution for 20 years as opposed to building a solution for next week, right?
Yeah, this should be able to power. A good analogy is we run HLS and Dash over HTTP. So we can run a lot of streaming formats over MoQ transport. We hope that MoQ transport is this base layer that perhaps has an evolution every couple of years, but it's otherwise pretty stable so that it can be deployed at scale by distribution networks. But then the applications that use it, they can evolve very quickly. I can make a new one on Wednesday and use it on Thursday, because as long as it's interfacing with the interface is consistent with the delivery network, then I can experiment as long as I control the publisher and the client.
So I'm going to ask if you'll pull up your second slide here, because we're talking about that with the application layer at the top. And while you do that, I'm going to say to the audience, if you have questions, there's a Q&A portion here within Zoom. If you'll go in and add your questions, we'll get to those probably in about 15 minutes here. Okay, so talk a little bit.
Yeah. So this is just what we're putting in some very simple pictures, what we spoke about with words probably 10 minutes ago. So at our basis, we have raw QUIC, right? That's the IETF-based invention that is helping us improve transport on the web. We have WebTransport sitting on top and leveraging QUIC. And then we have this notion of MoQ transport. So MoQ transport is the pub/sub protocol for moving binary messages. There may or may not be media, doesn't matter. And MoQ transport can go to raw QUIC directly or via WebTransport. Then on top of that, I mentioned we can layer a whole bunch of I'm calling streaming formats. So yet another use of the word stream. Some people don't like this, but I haven't found a better name yet myself. These are just, they're protocols for saying, you've given me this pub/sub network. What do I do with it? Do I want to build a chat system? Do I want to update databases, or do I want to do the Super Bowl? And we have a candidate for a streaming format that is developed by the working group, the MoQT working group, called Warp. So Warp is a media streaming format, and you can go read its scope. It will do real-time latency, near live latency, couple of seconds, and also VOD, and it sets the basis for doing tokenization, content protection, DRM, advertising insertion, analytics, everything you need in a modern media format, it's here. So I encourage people to help build this. I'm one of the editors. We have another one called low overhead container streaming format. And to keep us honest, we have a chat format too. We have a clock. We have other things for testing, right, that aren't necessarily media. And the decoupling is that this lower layer is what we would expect a CDN, to use the older word perhaps, or a distribution network to deploy. And then up here, you have your player and your application layer. So this is where nanocosmos would run in this layer, right? And they might leverage distribution from a CDN if they wanted to. So that's just a very simple overview of Media Over QUIC and how the actual transport fits in.
Okay, fantastic. So you mentioned the low overhead streaming format and Warp, and you mentioned HTTP with HLS and Dash earlier. One of the limitations, of course, that we've had from the get-go with those HTTP deliveries is you had to have a certain number of segments come down before your video could start. So inherently, you had to wait a certain number of seconds. Of course, we've tried to approach that in the market with low latency HLS and other things like that. What are the latency implications for sort of quick starting something, no pun intended, with MoQT?
They're they're actually curiously similar, except that we don't necessarily have to cut our media into blocks. So when you start HLS or dash, you have to start decoding at an iframe, right? And iframes, certainly in Dash world, are at the start of segments, and most HLS with CMAF today, that's also true. And those iframes are spaced out every 2 seconds or every 4 seconds, right? So if you randomly drop into the stream, you're either going to wait a bit for the next iframe, which means your join time is higher, but then you start quickly, or you're going to go back in time. We can quickly grab the last iframe, but now your latency has increased. You have to make this trade-off. This trade-off is exactly the same for MoQ transport. It doesn't change as long as we're using IPB frames to encode our media. But what you can do in MoQ transport is you can have multiple tracks. So if people know what HESP is, for example, or for low latency loaded day dash, you start having tracks with different GOP intervals. So I might make a joining track that has a GOP every 100 milliseconds, or an iframe every 100 milliseconds. And yes, it's going to be a high bitrate track, but I'm only going to stay on it for a little bit of time. I'm going to stay on it long enough to jump to my next GOP interval. And then after that, I'll jump up to the more efficient one that might have an iframe every 20 seconds. So we have a lot of, if you really care about minimizing join time, which interestingly is also the operation that lets me operate at low latency because I can switch out of trouble quickly, which I need to do if my buffer is very small. So both joining and leaving tracks quickly. Then there's some quite nice schemes that we can deploy with MoQ transport to enable you to do that.
So with the fact that there are these parallel tracks that are running, does that increase the bandwidth requirement to the end user because there are multiple tracks to be chosen?
No, the end user is only subscribing to one at a time.
Okay, fantastic.
But the relay might be pulling more. And in fact, one of the biggest problems with switching up or switching down with segmented media is you're playing, say, the 720p track, and you want to switch to the 360p because you're in trouble. So you make a request to the edge at the CDN. No one else is watching 360p. That CDN has to go all the way back to the origin and fetch it. And you're in a buffer situation, which makes it worse, and then you rebuffer, right? It would be cool if that 360p track was waiting for you at the edge. So in MoQ, we actually have the ability for the client to subscribe to tracks and tell the relay, and the relay is the word we use for server, a distribution server in a MoQ transport network. It tells the relay, hey, I want you to pull this track all the way to you, but I don't want you to deliver it to me. You just stop and hold it. And that way, it can pull the lowest bitrate track, which is its emergency track. And then if it runs into trouble and it switches down to that, it knows that that track is warm at the relay edge. And obviously that's a DOS vector as well, so we've got to put other protections in to protect it, but it's a performance improvement at the end of the day.
Yeah, and denial of service, yes, as you say, that's a huge issue. Let me ask one sort of adjacent question to that, then I'm going to come to an audience question on security. But the question there is, so in the old days with Windows media, where they would send multiple tracks through, which is what I was describing, the problem a client would have, where they'd have a 720p and a 480p and a 1 point whatever. You're saying essentially the end user's system can make a request to say, hey, I'd like this lower bit rate available. That's above and beyond the CDN's rules, where they say if we see people starting to fall into this range, we'll go ahead and pull this from the origin.
Yeah, CDN's not going to do that. The CDN is stateless and agnostic, right? This CDN will just respond to subscribe and publish requests. There's no application logic necessary to operate MoQ transport. The player would do.
All right, Oliver, let's talk a little bit about this overall model with caching and CDNs and like that. And you had a workflow that you wanted to show, so let's go ahead and show that. And while you're doing that, I'm going to ask Will a question. Somebody from the audience said, hey, what are the security implications for MoQ or MoQ transport compared to more traditional methods?
So the security implications are very consistent with what we see elsewhere on the web, right? We have clients that we don't trust. We have DDoS attempts. We have piracy. So one of the things we've built into WebTransport is first-class support for tokenization. So these are bearer tokens and more sophisticated tokens. And when you connect, obviously you can protect the connection using the same tools that we do to protect HTTP connections today. Firstly, you have a TLS cert to connect to where you're going, but then you supply a token that is authenticating how and when and from where you can actually join your MoQ web transport connection. Then within MoQ, you're allowed to publish, subscribe, fetch, track status. There's what we call actions that you can take. We can also protect your ability to do any of those. So I might say, Tim, you're allowed to connect from Germany between 5 and 8 p.m., but you're only allowed to publish if you're in Munich. I can and I can create a token that the client will be given. I don't trust the client, but the client's just given this token by an agency that it authenticates with. It gives it to the relay, and the relay can enforce those claims. And I have a prototype up right now called CAT for MoQ. It's Common Access Token for MoQT, and we're basically looking at leveraging what is becoming the common token to protect HTTP media and being able to leverage that to also protect media over quick transport. It's not the only one. People can bring their own token schemes, but and I encourage more people to actually develop token schemes so that we do have a robust security architecture.
Okay, good. Thank you for that. So Oliver, this this workflow for real-time streaming, we sort of got the WebRTC model, SRT model coming into QUIC, MoQ transport, web transport. Talk to me about why it's important to understand sort of the end-to-end model as you're looking to publish this way.
Yeah, let's get a step back and have a look at the workflow from an application point of view, because when it's about real-time streaming, real-time interaction, it's always end-to-end, and the latency builds up in the whole workflow, starting from the live encoder, which prepares the video, and the upstream, which is sending the live stream to the ingest point, which is still something like RTMP or SRT. So if it's tuned to low latency, it still works for real-time interaction. Sometimes it's using WebRTC and WIP. If you're on the browser, you can use WebRTC for ingesting to a cloud or to a CDN, but it's one of these protocols. So it's not QUIC yet, but that's probably coming also soon. Then it gets to the CDN, and the CDN takes care about the delivery in a global scale. It's usually also based on a TCP-based protocol transport, which we also did in the past, and that's a very important step for us to also upgrade that to QUIC and WebTransport. So in fact, we are using WebTransport as an interface, which Will was mentioning as a thin layer on top of the QUIC protocol. But as we have complete control here, you can decide yourself as a CDN provider what technology to use. And then the last mile is the delivery, which is then needs to be compatible to your end user devices, which is usually a browser, primarily on mobile nowadays. So you want to open up any browser, want to have immediate access to the live stream, and everything in real time to interact somehow, to maybe be part of a live auction, a betting, voting situation in that enterprise space, and ask some questions back to the presenter or so. And we see benefits for the QUIC transport, QUIC and web transport protocols in all parts of this workflow. As I mentioned, very important is also the middle mile, the live transport, when it goes to an international scale, sending a live stream from Germany to South America, for example. It goes several routes across the internet, and if it's an efficient protocol, which is based on UDP with better scalability and robustness against less head of line blocking, less packet loss, etc., it's a big advantage. And the last mile then as well. You might be in any hostile network situation anywhere in the world, might not even be in remote locations, but even in cities like Berlin, where I am, we still have sometimes bad networks. Switching from Wi-Fi to a low quality bandwidth network requires then adaptation. Adaptive bitrate can be put easily on top of these things. So that's the whole end-to-end workflow which needs to run in your application. And the challenge is to build an application based on these technologies and to decide which is the right protocol to use, because QUIC and WebTransport are not available everywhere yet. It's something like Safari on iOS doesn't support it yet. Other browsers don't support it yet. Some networks might not support UDP, so you might need to switch and fail over to another protocol. That's what we would do then with HTTP2 or WebSocket transport to really provide a successful live stream on the end user devices. And one thing I wanted to also mention here is the analytics part, because you need some insights into the quality of service of your application. So if things are going wrong, or just to get an idea about the success of your live streaming application, everything is running fine for all your clients, you need data. And getting this data requires also insight on all details of the workflow, and collecting the data from all parts of all components of the workflow is very important. And QUIC and WebTransport offer more possibilities to collect that, but still it's challenging to get this all together and bring to an application framework somehow. So that's the challenges we try to solve from an application point of view, end to end, and that's why it's important to look at that end to end as well.
Okay, thank you for having that slide. If you'll pull that down. Will, do you want to add anything in terms of the analytics side? Because obviously you work for a company that also has a CDN.
Yeah, what's very cool about MoQ Transport is it's bidirectional, right? So we have this distribution network, call it a CDN if you want, that can distribute media out to players. But at the same time, those players can publish their QoE stats. Instead of beaconing them to some centralized repository, which then has to handle many requests per second, it can simply send them back to the CDN on the other side of the connection. It's a bidirectional connection. And then an analytics company can subscribe to all these player feeds that are being published. So for the first time, the delivery surface also becomes the collection surface. And that's very scalable because they're both big. So I'm quite excited. There's a couple of drafts that have been established for logging already for Media Over QUIC. So we're going to standardize how clients can log both at the very low level QUIC layer and then at a higher up, like the actions within MoQ Transport. And the verbosity of that can be adjusted, but it's designed to be yet another data packet that is, or data object rather, that is sent over MoQ Transport, but in the opposite direction.
So if I hear you, let me see if I understand this correctly. In the old days, probably 6-7 years ago, we needed these real-time user measurements, or RUMs, sitting out on the network to measure. Essentially, you're saying the end user's player is acting as a RUM and sending its information back directly to the CDN.
Yeah, we have RUM measurement today for HLS and Dash. We have CMCD that we can send it back to the CDN. With CMCD V2, you can send it somewhere else. But you always have to collect it and send it to a collection point, right? It might be Conviva, nice people at work, MoQ, somebody like that, who's built a lot of servers that can handle several million requests per second. And that becomes challenging if you're doing very large-scale live events. So it is quite convenient that we can use the delivery surface to actually collect the QoE data, which we don't have to send it to one place. We can use every edge server to collect it.
Interesting. Okay, so 2 more quick questions before we go to audience. Interoperability is always an issue with sort of new protocols and that type of thing. How do we, in practical terms, how do companies building players that are reliant on MoQ or WebTransport make sure they're interoperable with what sort of the core transport is?
So yeah, it's hard now because we're building it, right? So it's like a multi-story building and you want to start decorating it with furniture, but every week another floor is added. So we're at draft 11 as the last one published. And it's roughly like every month or month and a half is a new draft. And these drafts have breaking changes right now. So if you're trying to build, interop is hard. We have interop events every 3 months, and there's teams of engineers working to try to make sure everything matches. And we have some interop today, but I would say it's pretty low because of the rate at which features are being changed. So we know this. The goal is to stabilize the improvements. And then as you do that, as you have a specification, especially one that's released as a draft, as an RFC, then you get your interop, right? And then we want to have very few changes to it going forward. We are designing extensions into it. So all the things we forget to add right now, we can extend them in the future by adding these custom extensions to objects without having to go ahead and revise the whole RFC. So that is built in.
And so do we have a general sense of when we'll reach a point that there won't be those non-breaking or those breaking changes?
Yes, I hope before the end of this year. But you asked different, like define done on a spec.
Sure. Fair enough.
It'll be done enough. So there's already cool demos that are done. And Oliver's deployed it, right? So he's just taken a slice and he controls both ends of the chain. He can deploy a static version. But his version won't operate with anyone else's yet. But clearly we want interop. That is the whole goal here. And for interop to happen, the RFC must be stable.
Yeah, I totally agree, but it's challenging for everybody. And we did the end-to-end solution deliberately because we noticed that it's really a big challenge, especially for non-experts who are not working in the video industry, to bring everything together, player from one vendor, CDN from another vendor, encoder from another vendor, etc. And then you need to switch protocols between different things like HLS dash and all these things. That's why we decided to bring everything together in an end-to-end platform and take the holistic point of view and the holistic approach here, which really makes a big step towards better user experience for our customers and still be based on open standards, because it's a great benefit to have these standards and to open up when needed and when possible, for example, to scale out maybe to CDNs like Akamai and use that as a point for better distribution on a large scale or so. But it really depends on the requirements and the use case, what is needed. And having something end-to-end is really great by yourself is a big challenge, including the whole tech stack.
Well, I was going to say, coming out of video conferencing, what we found was sort of this back and forth of we had standards, the ITU standards, and then we had proprietary features we'd put in. So Polycom would only talk to Polycom and do particular things. Polycom and PictureTel could talk on the standards. And it sounds like we're almost in that same kind of model here, where it's you at nanocosmos can do it. Then as the standard matures, you can come back and take a look at interoperability down the line. I guess the last question before we go to audience questions is, are there any royalties involved in this? And I have to ask that because whether it's a new codec or whether it's something else new in the streaming world, it seems like everyone wants to know, am I going to have to pay something extra to use this?
So no, there's no royalties involved. Now, can you say that there will never be royalties in the future? No, you can't say that about anything in our world, unfortunately. But the standard is developed with the IETF. They have a very open and active IP policy. Anyone who believes they have IP that is relevant to what is being contributed has to declare it up front. They cannot bake it in and come back 5 years later and say, haha, everyone is using it, you must pay. Because then they're guilty of contravening the policies under which the draft was created. So, you know, we have HTTP. That's an RFC. It's worked really well. No one's paying royalties for that. I very much hope that MoQ will be the same.
Okay.
Yeah. It's different like in the codec world, where you have these patent issues frequently. And these open standards, IETF based, it's much easier to handle. And I also don't see any issues in that domain.
Okay, fantastic. So let me throw the first question out here. The question was, UDP is primarily used in DDoS attacks. How do you mitigate the DDoS risk if you're opening up a UDP port on the server? And Will, I'll probably throw that to you since your company is a security company.
Yeah, I'm not the firewall guy. I fight the firewall guy trying to get my stuff through. So we're not going to open up like raw UDP. You're going to open up to UDP that looks and behaves like QUIC, right? Because that's what we need for HTTP 3. So HTTP 3 is growing. It's a large fraction. I don't want to misquote the fraction it is today of traffic, but it's very significant. So firewalls are going to have to handle that. There's certainly networks that block QUIC/UDP today. And yes, that's why WebTransport has a mode that operates over HTTP 2. And I hope that the necessity of that mode declines over time as the firewalls and, say, stateful inspection improve to the point where we can differentiate what is legitimate MoQ transport traffic from something that is a DDoS attack. But it's a valid challenge.
Okay. A second question was, QUIC appears to be used at scale for user-generated content, web conferencing use cases, but how realistic is it to use it for a live major sporting event?
Very, very realistic. Can I show like a 60-second demo? Do you want to? Let's see. Now, just bear in mind that I am scraping my screen, so quality-wise, you're not going to see it as clear as I am. But this is live sports distribution. To go to, I think it's Trevor's question. So I'm sitting in Zurich. I'm going to publish 1080p, 30 FPS, 5 megabits per second. Kind of typical of a sports feed today, although it could be 4K. I'm pushing it all the way to an edge relay, a MoQ transport relay in Los Angeles, which is very far away. This is a worst case distribution live sports problem. Normally we would stay regional. And then I'm going to play it back. So I'm going pretty much all the way around the world here. And I'm doing it on my laptop. So here I got OBS. I'm encoding my live sports content. I'm using that as the source, right? Then I go to a web page where I'm using web codecs to re-encode it and to publish it using WebTransport inside the browser and push it to my relay. So I hit publish there, and I've got the clock up. So if your eyes are super fast, you can see the delta. Don't worry, I'll take a screenshot later. And then I open up another web page and I subscribe to the same relay with the same stream. And it froze there because I'm also recording my screen at the same time. But here we have the entire workflow from source to publisher to subscriber, operating from Zurich to Los Angeles and back to Zurich. And if I go here and I took a screenshot, you can see I have a 30 millisecond delay between my OBS and my encode, which is correct. It's a low latency 1 frame encode. And then I had 636 milliseconds here, of which 149 milliseconds is the RTT between Zurich and LA. And then I had a player buffer of 400 milliseconds on top. So end to end, 667 milliseconds, which is good for live sports. It's very good considering I have full control over the codec that I'm using here. So this is obviously a very simple and early demo, but it was established just to prove that, yes, one of the targets for MoQ transport is really, really cool, really low latency live sports.
So that brings up a secondary question. Something that is sort of percolated in the industry for a couple of years is the conversation around, is latency or synchronization better? And synchronization meaning I have multiple streams coming into the same location, say a sports bar. As I understand, when you were talking about the tweaking, would it be potential, if you have one stream coming in faster than the others, that you could essentially dial that back where you keep the multiple?
Yeah, so sync and latency are decoupled. I can synchronize streams that are at 60 seconds latency, at 5 seconds latency, or at 200 milliseconds latency, right? I mean, I can't synchronize them lower than the lowest person's latency, but that's trivial. So there's many ways to do sync. We thought about sync with MoQ transport. MoQ transport itself will not sync anything. It's just a pub/sub network answering requests to subscribe or publish. The streaming format needs to define how the synchronization occurs. But yes, there's no reason why you can't have synchronized playout on your devices, but that is a decoupled action from the latency. You don't need low latency for sync.
So the final question from the audience was around UDP processing offload for NICs or network cards. And the question specifically is, are there expectations when we would see a hardware offloading of UDP to reduce the load on the CPU?
Yeah, that's a very good question from Renos, and probably a good point to talk about what are the negatives and challenges about MoQ transport, right? It's not rainbows and unicorns that we've been spouting everywhere. One of the challenges is QUIC is more CPU intensive today because of the user space work that's being done on the clients. Sorry, on the server and the client actually. So the cards are not everything is done on hardware. I've asked the same question to hardware vendors, and they say within a year or two, and I would go closer to 2, that they hope to start seeing cards coming out. If I'm old enough to go back and remember when suddenly people said HTTPS, we had to do media, and we thought, oh my gosh, we have to encrypt absolutely everything we send. That's so expensive. How can we build a business on that? And it turns out the encryption got very efficient and the cost came down, and now we take it for granted that we've got HTTPS everywhere. So my hope is that the QUIC stack moves to hardware, we get the same efficiencies there, and over time, we won't even think about it economically. But it's a very valid question today. It's more expensive to deliver QUIC, both H3 and MoQ than it is to deliver H2 for the same amount of bytes.
Okay, very good. That's a very good ending point. I'd like to thank both of you for your very, very good contributions, and I'm going to hand it over to Steve Nathans now.
Yeah, that was a great discussion. That was amazing. Thank you so much, Oliver and Will and Tim, and thanks to nanocosmos. And if you want to catch Oliver and Will again soon, they're going to be speaking at the Focus Media Web Symposium, June 24th to 25th in Berlin. That link should show up in the chat, and you can read more about that event. But I guess it's free, and they'll both be there. So if you want to catch them, and one more bit of business before we go. The walk-up music that you heard as we came in at the beginning was Nick Lowe and his cowboy outfit with Long Walk Back, and it was amazingly correctly identified by Renars Comex. Renars, I'm sorry if I'm mispronouncing your name, but you should receive an email within the next week or so in which your name will be pronounced correctly and informing you how to get your prize. So thanks again to all the audience for joining, to all of our speakers, to nanocosmos, and please join us back here at, 11:30 for our next session, Transcoding H.264, HEVC, and AV1 at scale. Hope to see you there.
Bye-bye.